Hello, everybody. I don't like this code. It's not problematic. It's not really bad either, but I find it annoying. There are a few chairs here in the front. I find it annoying, and the reason I find it annoying is this repetition. And it's not a problematic repetition. When we talk about software design and we talk about the dry principles, dry as in don't repeat yourself, this is not it. When we talk about dry principles and don't repeat yourself, we talk about things that are problematic when you have the same code structure duplicated in several places, because then you get trouble when you refactor or add new features because you're going to forget to update one of those places. This is not it. This is not a problem. It's just noisy because we have a lot of text that doesn't add any information. And that annoys me. I have this weird thing that this is really difficult in C++ because it's a weird language, but I really like it when I can read code like I read prose. It reads like human communication. And no one speaks like this, at least no one over age 3. So if you talk to a colleague about this assertion and said state equal idle or state equal disconnecting, etc., you would think that something's wrong. So yeah, I'm annoyed with that. This is the session Modern Techniques for Keeping Your Code Dry. I am Björn Fahller. I am professionally and avocationally annoyed with code. All code, including my own. Brief background, I work for Net Insight in Stockholm. We make networking equipment. Curiously, the TV radio infrastructure here in Norway is run on equipment that I have helped write software for. We do mechanics, electronics, FPGA design, low-level software that controls the FPGA, networking protocols, network management systems, network resource scheduling, a lot. We're also looking for talent. Just so you know. This talk is about techniques. It's not so much about this example. I'm going to use that example to drive the presentation, to show the techniques. And I'm going to do it in quite absurd ways. Bear with me. The reason I'm doing that is because it's a small example that is easy to follow and understand. And it gets me to show techniques without presenting a huge amount of code. So if we go to this, we have this state type and this assertion. And as I said, I'm annoyed with this. So what can we do to get rid of this annoying repetition? So we can try a variadic function template, sort of like this. A function template is any of that takes a state type and takes the alternatives that we're checking for. We test these with a fold expression. Who is familiar with fold expressions? Okay, a quarter of you. I'll briefly go through it. So the fold expression is this expression here at the return. It's parenthesized always, and it repeats variadic template parameters. So in this case, we have this sub-expression s equal t's that is repeated with this logical OR for every value of t's, no matter how many parameters there are. Fold expressions are a huge saver of trouble huge saver of repetition when you're working with variadic templates. The alternative is pretty much to either do horrendously ugly tricks with I don't know, initialize a list or whatever, or use recursion. And it's not good. So full expressions, remember those. But then we can write like this. Assert is any of state, idle, disconnecting, disconnected. And this is really bad code. This is really, really, really bad code. Sure, we got rid of the repetition, great. Only problem is that no one can understand what this means. Not without looking at the function body to see what it says. So it's important, I think, that you in code try to convey meaning to the reader of the code, and this doesn't do that. It doesn't say anything. You cannot know that the first parameter relates with the logical OR to each of the others. So let's not go there. It was bad. Let's try a variadic non-type template parameter function template. That is so. That's poetry. So we can write like this. Is any of that takes a state type, and we have as template parameters several state type values, and the fold expression that you have seen before. So state type can be used as a non-type template parameter because it's an enum. Enums are easy to handle in this way. And then we can write the code like this. Is any of idle, disconnecting, disconnected state. We can generalize this a little bit more, especially if we're in C++17. We can use auto for non-type template parameters. And then we can use a T for the value we check. And then we can use this for many types. I won't say any types, because that is not true. But we can use it for other enumerations. The downside is that not all types can be used. Enumerations, const expr integer values, I cannot have a variable there because it's a runtime value, it cannot be checked. And the problem with the solution, some argues that this really is not a problem, and I guess they're right. But they're not as annoyed with code as I am. So, and that is that this is Yoda speak. If you're familiar with Star Wars, how Yoda speaks in backwards grammar. And I said that I like code to read like human language. And this is not it. This is Yoda language. So it's not a problem. It's fairly readable, but it's also quite limited. So I'm not super happy with it, but it's not that problematic. And then we can try something else. We can construct an object and then do tests. So we're sort of turning it a little bit inside out. So there was sort of an informal competition on Twitter a few years ago about who could write the smallest check for if a value is in a set of values. And I think this example won. I'm not sure. I haven't found any that was smaller. This was when Twitter had a limit of 140 characters. With the Godbolt link. So let's try this in a slightly more readable form. So we have a function template is in that takes a value. And we use, from C++17 and later, we can use the auto return type on a function. So we return a lambda that has captured this value t. And the lambda is callable with a number of values. And we return the fold expression that you have seen several times. You understand how this works? Anyone having trouble? Peter?
I see two const expressions missing.
We'll get there. Don't rush it. Don't rush it. We'll get there. For those who didn't hear, Peter commented that const expr is missing. That is true, but I'm ignoring it for now. I'm actually ignoring a lot of things to begin with, just to set the stage.
Oh yeah, lambda is implicit.
So now we can write like this: is in state and the alternatives. So when we call is in state, it returns this lambda, and then we call the lambda with the values idle, disconnecting, disconnected. Sure, great. So the good thing is that this now works with all types, provided that the equality and the logical OR operations works. But it looks absolutely horrendous. You don't want to write code like this. I don't. Especially I don't want to read code like this. It's too terse. There's information missing. So let's try to refine it a little bit more. We can explicitly construct a type where we have a member function that has a name instead of just the call operator. Like this. So we have the is template. And we capture the t then as a member variable. And we have an any of function that we can call. So this is logically exactly the same. Then we add another C++17 thing because why not? So if you're not familiar with this, is a deduction guide. A deduction guide is that in C++17 there is this thing called constructor template argument deduction. It's often referred to as CTAD, where you can. It's sort of a generalization of how template parameters are inferred from function template calls. But in this case, it's for constructors. So we can say that if I'm calling is with 3, the compiler sees that 3 is an int. Therefore, I assume that you want to construct an is of int. And the deduction guide is here to help it. There are situations where the compiler can figure this out itself. But this syntax here, template type t is function call t, arrow is angle brackets t, is a deduction guide that helps the compiler to say that if you see an is instantiated with a t, assume that it is an is of t that we want. To get more information about this, I really recommend that you watch Stefan Lauerweid's talk from CPPCon last year. Almost exactly to the day. And when you have watched that and think everything is absolutely awesome, then you look at Timo Dumner's talk where you see that it's a trap. Both are really good. Watch them. So with this, we can now write is curly braces state any of. And this works. This communicates. Communicates intent. It's explicit. It's still Yoda speak, which annoys me, but not everybody. So, yeah, I think this is fairly useful, or at least usable. And then time passed. Oh, sorry, Peter.
If you go back one slide, if you're using is with the curly braces, do you even need the C tag?
Do you mean, do I need the deduction guide? I think so. I tried this example without because I thought we wouldn't need to, but it didn't compile. Peter?
I guess you need the deduction guide, otherwise it wouldn't be able to know how to use t because you don't have a constructor that more or less gives you the implicit deduction guide.
Yes, so Peter's guess is that if I had a public constructor that takes a t, then the compiler would be able to deduce it. But since it's just a struct with a data member, it's not able to. I think that is the case. So after this, time passed. This is not an important problem. I'm not spending huge amounts of time on this. So, but I am sort of mildly annoyed. And then one day, 2 years later, is this too cute? So I have a class any of that inherits from a tuple of t's, and we have a templated operator equal. and we can then write code. Is any of 1, 3, 5 the same as x? And we can have obviously a commutative operator equal to make it less Yoda-ish, as Peter commented on the next tweet, but it's not on the screen. And yeah, I'll talk you through this with slightly more readable code, I think. The code formatting in Twitter is a little bit bad. So we have a templated any of that templated on type name T's. I'm super lazy, so I'm using private inheritance, and the only reason for that, I mean, what you really should do is have the tuple as a member. But tuple has 18 constructors, and by just saying, hey, use the constructors from tuple, you're done. Okay. Shoot me, I'm lazy. It works. Private inheritance is, I don't know, I guess it's sort of frowned upon, but it's sometimes useful. Especially, I think I've seen too many cases of public inheritance where you're actually not trying to express an inheritance hierarchy, you're just inheriting implementation, and doing public inheritance there is really wrong. So don't do that. Anyway, I digress. Operator equal uses stood apply. Stood apply is amazing. Stood apply takes as the first parameter something that is invocable, a function, an object with a function call operator, what have you, and then it takes a tuple. And then it calls that function invocable thing with each of the tuple's members as the parameters, and that is so good, so amazingly good. Unfortunately, in this case, my laziness causes me trouble, because since I have the private inheritance from tuple, I need this ugly static cast. Because to apply takes as the second parameter, it's a t. And when the t then is an instance of any of, and it has private inheritance from tuple, so the implementation of the apply cannot see the tuple. So I have to do this ugly static cast to make apply work. But it does work. And then I have the deduction guide, again, saying that if you see any of with these t's, then please try to instantiate an any of with the type t's. And the symmetric commutative operator equal, because that makes the code easier to read, and it just makes sense. If you say that you can express A equal B, then you really should be able to express B equal A. Otherwise, your code is horrible. And then I can write like this. A certain state is any of idle, disconnecting, and disconnecting, and I'm ridiculously happy about this code. It's exaggerated cuteness, but it just sparkles joy, I think. So I felt really happy when I discovered that I could write this. So let's have a look. Is this good or bad? Any guess? Let's have a look. So we have the state type. We have any of, it's exactly the same. The deduction guide. I have a class C here that happens to have a state and a function. And now I have tried to say that I have using an if-def here just to show two codes in parallel. So in this case, where the plain macro is defined, I'm using the traditional way of writing is state equal idle or state equal, etc. And if plain is not defined, we have this state equal any of. And if we look at the compiler panes, we see that the right one has -d plain, so it defines this macro. Can anyone see any substantial differences in the generated assembly here? No. Compilers are cool.
It's not tell you in the move before calling assert.
Sorry, I didn't hear.
It has different constant in the move before calling assert, but that's the only difference.
Yeah, the strings are different in the assert call. That is what differs. So we can conclude that doing this is, regardless of your opinion on writing code like this, we can conclude that it does not make the generated code any worse. It's identical. So that is cool. But when we have done this, we might as well add some relational operators too, for a less than, greater than, etc. So I can add a less than here to say that if any of A, B, C is less than 0, as below. And do note these ... dots here. There are a number of more operators. I just don't have enough screen space for them. Sorry. So it's a lot more code here than it looked like. But this allows me to write code like this, and this makes my nerd heart pound really hard. This is so great. It's absolutely amazing. So let's look at this. So I have pretty much the same thing. I've added operator less than, and I have a loop where I'm calling this update function on the references. And while any of A, B, C is less than 0, then keep looping. And again, the compiler generates absolutely identical code. That's pretty neat. I really like this. But we have a problem. So we have two functions here that are identical, save for a few characters. And it's not just two functions. Like I mentioned, we have less equal, greater than, greater equal also. And so this looks really bad, and it's worse, several times worse. And what more, I ended up here because I wanted to solve something that can best be described as an aesthetical problem. It's not really a problem. And now I have caused a real problem. This is the kind of repetition that the dry principles talk about. This is repeating structure in a way that invites to making mistakes when you make modifications to the code. So this is bad. So that was this was maybe not the step in the right direction I thought it was. I mean, sure, you can argue that, yeah, we have this ugly repetition that has a problem, but we have sort of squirreled it away in a library, so users don't see it, and that is a correct observation. But like I said, I'm annoyed with code. And this annoys me a lot, even more than the problem I set out to solve. So this is bad. But, okay. I'm adding a helper function, a function template, something that takes something invocable and a set of tuples, or a tuple of a set of values, and just to apply to call that function of each t and or the results. So this is a nice helper. You're familiar with this fold expression now. And I can rewrite the code to say that I'm calling or elements of this simpler check. Is the value equal, or is the value less than, or etc., etc. Still a fair amount of repetition, but a lot less. So, okay, we're beginning to maybe go in the right direction again. let's have a look. It's an indirection. What's the cost of an extra indirection? So we have OR elements, and I'm using OR elements. The rest is the same, including the generated code. Did I say the compilers are awesome? So yeah, so we don't have to fear writing code like this, at least not from a performance point of view. So say I want to add more than, I have this any of, it's useful. But maybe I want an each of that it does a logical AND instead of logical OR. Do I repeat everything again? That doesn't sound like the right way to go. But if I change my OR elements from being a freestanding function template into being instead a type that has a member function template, a static one, then I can do another indirection, and I apologize for this appalling name, opt. My imagination failed me there. Opt takes an operation, and the rest is like you've seen. But the call to apply is changed to this op : apply there. So now we get, if we have an opt where op is OR elements, then we have exactly the same code as we used to have just a few slides ago. And then the any of is something that inherits from opt of OR elements and t's, and use all the constructors. I'll get there soon, very soon. So now I can make AND elements instead, and each of. And the only difference really is not very many changes at all. So I have some power here in the reuse from the templates. So that is nice. But now for your observation, Seth, about using an alias. The problem with using the alias is that we cannot write a deduction guide for an alias. Yet. Yeah, sure.
People are claiming to do that, but not there yet.
Yeah. Unfortunately, my time machine is slightly broken, so so I don't have it. I know that causality is
Issues that I'm not aware of.
Causality is severely overrated, but still, I'm not able to write deduction guides for the alias yet. So therefore, we have to have this construction. And you probably already guessed what I'm going to show you. So now I'm having this each of with AND elements. And this is not working well. AND elements has this logical AND instead, of course. And now I'm looping as long as every single one of A, B, and C is less than 0. And the generated code is identical. This, by the way, may surprise you, but I've checked this. This is Clang now. I've checked this with GCC, and I've checked this with MSVC. And even MSVC does it right. So this is not a Clang thing. This is for real. I guess I will get comments about bashing MSVC. So originally, I intended to be finished here now, because I think what I've showed so far is pretty cool. But I think lambdas are kind of cool. We want more lambdas. More lambdas. So I have to add some slides about lambdas, like half the presentation more about lambdas. So I have a tuple here. Tuple is a lambda that takes a number of parameters and returns a lambda. Can you see how I can claim that this is a tuple? It's not a very good tuple. It's definitely not stud tuple, but it is a kind of tuple. So when I call tuple with some values, it returns a lambda that has captured those values. That is sort of tuple-ish. And this lambda can be called with a function. This function could be, for example, give me the first element, give me the last element, give me the number of elements. So it's a tuple. It's a weird tuple, but it's a tuple. And it works. It works for what I want to do right now. So when I'm calling here tuple ABC, then I get this lambda that has captured ABC. And then I'm calling that lambda with a function that does this e greater than and a logical and fold expression. So these together means, in other words, expands to a greater than 0 and b greater than 0 and c greater than 0. And then we can, of course, use the techniques I showed earlier about this AND elements, but I'm using, again, with just more lambdas. So AND element is something that takes a function, returns a lambda that, when called with a number of elements, applies this function to these elements. So when I'm using this, like this, I'm calling AND element with something that just does a greater than 0 comparison. And AND elements of this greater than 0 is the function that we call to the tuple. So again, this expands to a greater than 0 and b greater than 0 and c greater than 0. Are you with me on this? Or is this a little bit sort of painful for the synapses? If you haven't done any functional programming at all, I assume that this looks really weird. Then we can go a little bit further to get more things. The C++20 library will get a function bind front that you can call with something that is callable and a number of values, and it returns something that calls this function with the bound values and any other parameters that you add. But there is no bind back. And for the purpose of this presentation, I didn't want to spend too much time on explaining how to do this super general. So I have a bind right hand. That's what RH means. So bind right hand takes a function and a value. And it returns a lambda that is callable. It assumes, by the way, that the function takes 2 arguments, exactly 2 arguments. Otherwise, this will not work at all. When we call this return lambda, we call the function with the parameter of the function call and the captured value. And this is useful, because now we can define a greater than, in this case, that takes a value and returns the bound right-hand value to stud greater, which means that we can write code like this. And elements greater than 0 on the last line. So now greater than 0 is calling bind of stud greater than and 0, and we get the and elements that is called with values, and it compares, is this value greater than 0? And we're getting that as the function to the tuple. So again, we get exactly the same: a greater than 0 and b greater than 0 and c greater than 0. So now we can start building these each of and any of again. So we have the tuple and elements equal to, greater than, etc., a number of others, and this horribly named opt. And when I call now each of ABC, it calls this each of function that returns an opt of and elements and a tuple of ABC. And opt's constructor takes a function and a tuple, and the function then is and elements that we store as a member func, and the tuple that we call store as a member tup. And then we do a greater than 0 comparison where it calls apply greater than t, which makes kind of sense for a greater than. And apply calls the tuple with the function that is greater than and elements and greater than for f. Whew. A trick they can use, or not a trick, if you have C++20, you can use no unique address. It can save you a little bit of memory. In this case, function doesn't have any members. It hasn't captured anything, so it doesn't take any space. By saying no unique address, you say that it's not important for me to be able to address exactly where in memory func is. Normally, the rules say that objects of different unrelated types must have unique addresses. Therefore, in effect, an empty type does take 1 byte. But by saying no unique address, we say that, never mind, I don't care. Pre-C++20, you can use private inheritance. We have, since forever, pretty much, had the ability in the compilers to say that if you inherit from something that doesn't have a size, then it doesn't add to the size of the object. So this, in effect, creates the same thing, but with less horrendous syntax. And this is weirdly beautiful, I think. And I have to show you, I've changed the example a little bit here. By the way, if you feel uncomfortable with these examples from Compiler Explorer, go to Anders Knatten's talk tomorrow about enough assembly language for Compiler Explorer. Okay, so we have tuple. I forgot to rename this one, or members. We have bind right hand equal to less than. We have our opt. And we have an any of that calls the or. Now I have a function that I take a string view and I'm searching for the first white space character. So I'm using the standard library std_find_if in the range of characters for anything that is equal to any of tab, line feed, character return, or space. Note that equal to was something I wrote just as a helper to implement the equals operator, but it's a higher order function that is applicable to any types that make sense, so why not use it here? And I really like this code because this reads like a human communication. You say search for anything that is equal to any of tab, line feed, character return, space. But it's cute. So let's see what the compiler has done. We get the size of the string view. If the size is 0, we're done. We get a really, really big value into R8. Any guess what that is? Sorry? No, it's not MPOS. Good guess, but it's wrong. If you look at it in hex, does this help? 10002600. This is a big number that has 4 bits set. More precisely, it has bit 9, 10, 13, and 32 set. How well do you know your ASCII table? So yeah, tab is 9. So 9 is set. Line feed is 10. Bit 10 is set. Character return is 13, so bit 13 is set, and space is 32, so 32 is set. So it's a bit mask with these values. So what we do is we get a value, compare it. If it's greater than 32, it's obviously not a white space. Otherwise, we check if the bit is set. If it is, we have a hit. We're done. Compilers are pretty awesome. And this, from writing this this code, this is not low-level code. This is not bit fiddling. But the compiler generates really awesome code in here, I think. I was super happy when I discovered this. But happiness does not last. I'm sorry, it doesn't. It just doesn't. There's some things to improve. Const expert, Peter, finally. And it takes so little to add const expert to this. We have const expert to these member functions. Tuples are const expert by default if they can be from C++17 and later. So we don't have to do anything with those. It's just done. Cool. So now we can actually use these in static asserts, for example. It's already there. That's cool. Perfect forwarding. Everything I've written copies everything, everywhere. That can have performance implications. And conditional no except. There are some cases where when you write a generic algorithm where you can make more performant choices if you know that the code you're calling cannot throw. So you can have if const expert checks to see, can I use the efficient path where I know that nothing is throwing or not. Unfortunately, I have to tell the compiler if my expressions are no except or not. And this is sort of infectious change. I'll show that soon. And explicit return type. This is maybe less important, but there are two reasons, in my opinion, why you want to state the return type explicitly. And for some really odd reason, the return type itself does not have much to do with it. It's to do with the first, for me anyway, is that it has to do with what is called SFINAE. We're really good at making abbreviations for things. Substitution failure is not an error. And if we can say that a call for operators that does not match cannot generate valid code, and we can do that already when trying to figure out what the return type is, that means that that function is discarded from the overload set, which means that you get two benefits. One is that you get better, shorter, more to the point compilation error messages. People always forget that. Because what you get is an error message saying there is no matching call for this function with these parameters. And then it lists saying, yeah, this could have been an alternative, but it was discarded because of. If you don't have this, you get this avalanche of terrible things where you see that something is wrong in the implementation of stud greater. And you're not very happy about that, I presume. The other is that this is more trickery for advanced library programmers, where you sometimes may want to prune the possible overload sets and do different things depending on what is possible. I'm not going there, but that exists. So let's have a look at perfect forwarding and elements. We can capture by perfect forwarding simply by saying, yeah, func is stood forward of the type of func, whatever that is. This decal type here sort of makes me sad. It's ugly, but it worked. C+20 gives us the possibility to be explicit about what the types are, template types. Meaning that we can write the ugliest no-op ever by saying square brackets, angle brackets, parentheses, and curly braces, and then call that, and we have done absolutely nothing at all. But having access to the template type is sometimes useful. I think it makes the code a little bit easier to read. I don't like having sprinkled decal types in my code if I can avoid it. This one is more tricky because there is no way in C++14 or 17 to do perfect forwarding on a parameter pack. So either I capture everything by reference or everything by value, and by value I mean by copy. C+20 gives us this strange syntax for capturing the parameter pack. Note the dots at the beginning. It's not pretty, but it works. And again, we can be explicit about what the template types are. And then we use them, and it works. The code is becoming a bit cluttered, I think. But it has the potential to perform better. But then we get to conditional no except, and now I'm getting sad. Because what we need to do here is to say that something is no except if whatever it does is no except. So if we look at the first one, the tuple, the first no except takes a boolean true or false. Is this no except? And the second no except, the inner one, is a compile time predicate that just reports is calling func with t's. Is that no except? And then we have the same thing for and elements. So this means that yes, this lambda, calling this lambda is guaranteed to not throw any exceptions if calling func of elements logical ANDed is guaranteed to not throw. And yes, you do need the double parentheses because the inner no except takes a parenthesized expression and the fold expression must be parenthesized. So yeah. And this repetition is not nice. I know only one way to get rid of that, and that is to use a macro, and I hardly dare to say that when Peter Sommerlad is sitting on the front row.
There were attempts to get no except auto.
There were attempts to get no except auto, yeah. I hope we get a solution to something like this, because it gets even worse when we, this is just the same, more ugly repetition. It gets even worse when we get to the explicit return type, because what we do then is, again, we say that, yeah, a return type from calling tuple with func is the decal type of func of t's. And this is quite silly. And again, currently there is no solution to this other than writing horrible macros. You can watch Vittorio Romeo's presentation. You must type it 3 times. And I think the question there is the obvious question. Why can't the compiler do this for us? It should. But it can't, currently. Sorry. So here are some repetitions that I'm afraid I don't have any solutions for. The last 2, conditional no except and explicit return type, fortunately you often don't need them. So but if you do need them, there is no way around this. Sorry. So, yes?
What's wrong with saying that that operator equals returns bool?
What's wrong with saying that operator equals returns bool? It's perfectly sane. But there are insane people who overload logical OR to return something nuts. And if you want to be very generic.
If people are building expression templates?
If people are building expression templates is an example, yes. So it depends on how generic you want to be. But let's say that you had written this and returned bool and I was reviewing your code. I would probably not beat you for it. I could maybe mention that there could be more general situations. Seth first.
From the discussion that arose in the include Discord when we saw a few things of your talk there, where Nicole wants 0 smaller than any of ABC smaller than max. Then you would need to overload those operators to return something else than a bool that then is able to convert to a bool when needed. So yeah.
Yeah.
That's when expression templates come in.
Yeah. So to paraphrase expression templates. Sorry, Seth. Peter.
Yeah, there is a way to get that. Write a standards proposal to get that automatically deduction.
Yes. Thank you, Peter. I must say what Miku used to say in these situations. When the standard isn't what you like it to be, then it's your fault because you haven't tried to change the standard. It's okay if you have tried and failed, but then you have a right to be upset. But if you haven't even tried, it's your fault. So
You might need to implement it in one of the major open source compilers first to actually get it into.
yeah, okay. So yeah, Peter's comment again was that to get the proposal to be accepted, it really helps if you have a working implementation to show. So that was modern techniques for keeping your code dry. I'm Björn Fahller. Remember that fold expressions are awesome. And tuple and apply are awesome. And higher order functions are awesome. And lambdas are awesome. And C++20 lambdas are awesome-er. And compilers are awesome. And Svina no except is awful, I think. Actually, the functionality is awesome, but the way you have to write your code is awful. And sweating the small stuff makes you annoyed, but it can lead to neat code. Keep your code dry. Thank you very much. Questions?